The two-wire interface consists of two signal lines named SDA and SCL. SDA stands for serial data whereas SCL stands for serial clock. In addition to this, a ground line is necessary to complete the circuit. If you refer a development board or any products based on microcontrollers, then you should find a IC8255 used. This is a parallel port expander. I am discussing this IC here as to highlight the advantages of TWI over old age designs. The 8255 IC used to convert one 8-bit port to multiple 8-bit ports. These multiple expanded ports were used to connect with other parallel interface devices like ADC, keypad etc. In this type of design at least 12 pins of the microcontrollers were used. But with the introduction of TWI, we require only 2 port pins of a microcontroller to do the same interfacing job provided the device is connected to it supports TWI protocol. Let's see a graphics on the next screen. The graphics shown on your screen describes the TWI connections. As the microcontroller acts as the boss, is called as master. Rest of the devices are called as slave as they will be acting on the commands sent by the master. The slave devices could be a 24C256 EEPROM or a serial ADC or a real-time clock. The task accomplished by TWI and using a 8255 chip has no big difference. Finally, in both the cases, the microcontroller interfaces with other peripheral chips. But there is a major difference from design point of view. Using TWI, you save space in complex PCB designs. You can add extra devices to the same bus of SDA and SCL anytime. Your application also becomes simple to write. The next screen will show the TWI communication format. The SDA line is used to transmit and receive data. The line is used by only one device at any point of time. As the microcontroller is the master, it decides as which device should listen and talk over this line. All devices connected to this data bus gets a clock pulse via SCL line. All devices read the data from SDA line when SCL line gets a high signal, which is represented by 1 in the graphics on your screen. When I say devices here, it indicates a chip like 24C256 or DS1307 or any other IC or any other product which understand the TWI format. Now the question remains here of controlling multiple devices on the same and common line. How is it achieved? Answer is really simple. Master microcontroller send the address byte over the SDA line before sending any real data to the target device. Each device like 24C256 or DS1307 has a built-in address. Device address value is mentioned in the individual datasheets. One such address is shown on your screen. Thus by now we have understood that TWI is made up of 2 lines, namely SDA and SCL. The SDA line is used for data communication in both the direction, and SCL line is used as clock pulse line which helps the devices hooked on the TWI bus to retrieve the data. Master microcontroller sends 1 byte that is 8 bits address value on the bus before sending any data to the slaves. Let's move on to the next screen now. After sending an address byte, further communication depends on the individual device. You should refer the datasheet of particular device to understand further commands. Further chapters will explain the TWI command formats for 24C256 and DS1307 devices. Use of TWI is restricted to the few meters. Thus you cannot use it to control devices placed in various rooms of your home. TWI also eliminates the requirement of frequency rate as required by RS-232 format. Move to next.